Hello everyone, my name is Monit. Today we'll start AS and A-level physics paper 5, that is planning, analysis and evaluation of Feb March series 2020. Paper code is 52. Before going on to the question solving, let us first of all go to the instructions. Please read all these instructions carefully before attempting the paper. Okay, fine. Question number 1 says, a bar magnet attached to a spring. This is a bar magnet shown to us which is attached to a spring. This bar magnet is displaced a distance x. I have to displace this bar magnet at a distance x from its equilibrium position and released. It then oscillates vertically. If I release this in the vertical direction, it will start oscillating. A student investigates how the maximum induced EMF in a coil placed below the magnet depends on X. Here the student is investigating the maximum induced EMF in the coil when the magnets and how it depends upon the displaced, how much it has been displaced. The magnet has been displaced vertically. A coil is placed here just like this. Also, it is given that the suggested relationship between the E and X is given to us, where there are different variables. B is the magnetic flux. We should know all the variables in the given equation. Magnetic flux density at one of the poles of the bar magnet. Similarly, N is the number of coils and the number of turns in the coil. K is the spring constant. M is the mass of the magnet, and alpha is another constant, where X is already given to us, that is the displaced distance of the bar magnet. Now what we are supposed to do is we have to design a laboratory experiment to test the relationship between E and X. E is the maximum EMF and X is the amount of distance that we have displaced the bar magnet. Also, we have to explain how our result could be used to determine a value for alpha. Alpha is a constant. We have to determine the value for the alpha by using this given equation. Also, what are we supposed to do in order to plan an experiment? You should draw a diagram on page number 3 showing the arrangement of your equipment in your account. You should pay particular attention to. If we talk about the ideal planning of an experiment, these are some important points that we have to look after. The procedure which you are following, the measurements which you are taking, the control variables, the analysis of the data which you have collected, and any safety precautions that has to be keep in mind while performing the experiment. Now I hope you have understood the question, because understanding the question is more important before you plan your experiment. I suggest my students to give a rough idea on a rough paper or a rough sheet how you will plan, and then accordingly write down your answer in the answer sheet, because once you have write it down and you want any improvement, it will be very difficult to alter your answers, because the space provided for the question is limited. Also, you have the limited time. So please go through the questions, write down the basic points which you will keep in mind, how to what are the instruments that you have to add in the diagram, what are the method you have to follow, what are your control variables and all. So on behalf of that, I have prepared an ideal answer. It may differ from anyone's point of view, but according to me, what I suggest my students to follow is like this. Okay, so the first is the impression for the examiner. Whoever is checking your answer sheet goes to the diagram what you have drawn. Keep it as detailed as possible. If you labeled it very neatly and correctly, it shows a good impression on the examiner. Okay, so what I have suggested for this particular experiment, I have kept this spring with a bar magnet and I have clamped it with a rigid stand, and just vertically below I have kept a coil, and that coil should be just vertically below the bar magnet, and this curved area, or you can say the curved coil, should have the greater radius than the bar magnet, so that it can easily go inside the coil without any hindrance. And I have connected this coil with a voltmeter, because the voltmeter will give me the value for the EMF maximum induced in this coil when I displace the bar magnet. Also, I have placed a meter rule just aligning with the coil attached with the stand, so that I can measure it properly how much I have displaced, because there are two variables, one is E and other is X. I will discuss what is the dependent, independent and control, but right now the X I have to measure, so I have given one X1 which is my equilibrium position, X2 is my displaced, how much I have displaced, and the difference is the displaced part, or you can say the extension in the spring. One thing I have also added here is Hall probe, because if you see the equation given to us, in order to calculate the value for alpha, I should know all other values. Then only I can determine the value for the alpha. So here it is B. So in order to calculate B, I have used a Hall probe that will directly calibrate the value of magnetic flux density near the poles of the bar magnet, and we can easily find out by counting the number of turns. K, that is spring constant, we have done it in the method part. Mass we can directly calibrate with the weighing balance, and rest E is calibrated by the voltmeter attached to the coil. X we can measure by the meter rule. So all in all, here I can calculate each of the value given in the equation by using this diagram. This you have to keep in mind. Whatever the equation is given to you, all the variables should be easily be understood by the examiner by showing the diagram, that yes, you can count, you can calculate it easily. So this is the diagram for the question number 1. Now coming on to the writing part, how to plan your experiment. In order, it is not mentioned here aim, but I suggest my student to write down the aim so that you keep your focus on that particular aim. So to test the relationship between E and X is our aim, and by using that we have to determine the value for alpha. This is the required part of the question. Now first and foremost is your independent variable. So if I talk about independent variable, that is your distance x from its equilibrium position. Because in each and every step what I supposed to do is I will change the value of extension in the spring. So in each step I will take different readings by changing the value of x. So it is my independent variable. Whosoever quantity which you are changing, that is your independent variable. And on that behalf, what is the effect? That is your dependent variable. In our case, the electromotive force, that is the EMF in the coil, is the dependent variable. So if you change the x, the value for the E will also change. Okay. Now that is your control variable. What are the variables that you are supposed to control while performing your experiment? So I will not change the mass of the magnetic strength, that is I will not change the bar magnet. I will keep the bar magnet same throughout the experiment. So by keeping the bar magnet same, I can keep mass and magnetic field strength of the magnet as same. Number of turns, I will not change the coil, the turns will remain the same. Spring constant of the spring, it means I will not change the spring, and I will check that either the spring is getting permanently deformed or not. That I have to keep in mind. So these are the control variables, because if any of the variable value changes, that will affect my result. So you have to take in keen interest in keeping these control variable constant throughout your experiment. Now how to follow? The first point in the method, I have written that measure the equilibrium length, that is x1. I have also mentioned x1 in the diagram. So this is my equilibrium position of this spring. I have measured it using the meter rule. Using a meter rule as shown in the diagram. Now displace the spring downward towards the coil. You have to displace this magnet towards the coil. And measure the displaced spring length, say x2. How much you have measured, you can calculate by using the meter rule attached just parallel to it. So the extension x of the spring is x2 minus x1. That is the extension of the spring from its equilibrium position. That is measured. Also at the same time, measure the maximum EMF induced in the coil using voltmeter by video recording in slow motion. What does this? This is very important point here, that I have to measure the maximum EMF by video recording it and playing back in a slow motion, because the reason being, when you displace the bar magnet, the magnetic field associated with the coil changes. Due to change in the magnetic field, there is an EMF induced at the two ends of the coil, and that is measured in the voltmeter. By the deflection in the voltmeter needle, we can calculate the maximum EMF, how much needle has maximum deflected. And this process is so quick that for our human eye it is very difficult in order to realize what is the maximum EMF induced when I just displace, because it will starts oscillating. It will go up and down, so the needle will constantly deflecting in different directions. So what I have done, I have kept a video recording of this voltmeter. So in a slow motion, in a playback, I can see that yes, that is the maximum EMF induced when I displace the X. So this is very important here. Okay, so I have done X and E in the first point. Now in the second point, repeat the above step at the same extension X for more accurate by taking average value of maximum EMF induced in the coil. I will repeat the same with the same displacement in order to get the mean value for the maximum EMF induced in the coil. Because if you take one reading, you will note down. If you take two reading, three reading, at least three readings should be taken at the same displacement or the extension for more accuracy. And also take at least 5 different readings by taking 5 different value of extension. You have to take 5 different extension and repeat the same experiment as above. In the third part, I have devoted according to the control variables, that are measure the mass m of the magnet by using a balance. You have to explain how you will control the variables and how you will measure it. And magnetic flux B by using a Hall probe by placing it at one end of the pole. Also, to maximize EMF, take large number of turns of the coil. In order to maximize the induced EMF in the coil, one thing we can do is we can increase the number of turns in the coil. And to measure spring constant, that is very important. How you will measure the spring constant, that you have to mention it using K equals to Fx, that is the formula for the spring constant. Here F, that is the force, is what? The weight of the bar magnet, that is mass into gravitational acceleration. So mass of the magnet and X we already know, G is the constant term. As they all are kept constant by keeping the same magnet, I have shown here at the last that how I will keep that in control. By keeping the same magnet, I can control the mass and the magnetic flux density and the spring. So by keeping the same spring, I can control over the number of turns as well as the spring constant throughout the experiment. Okay, so this is very important, how you control and how to measure the control variables. Now on behalf of what we have done right now, we have to tabulate a reading, or you can see the collection of data. Here I have written serial number, how many times I am taking the reading, let us say 5 times. Equilibrium position in centimeters, because we have taken the meter rule. So we can write down the readings in centimeters here. This is the displaced position x2, again in centimeter, and the extension by calculating x2 minus x1. Here we can write in centimeters. Now by using the playback video recording, we can calculate the maximum EMF for a given extension. So this is the tabulated or the collection of data which we will do for the given experiment. Now using the above table, we will plot the graph of E on the y-axis, that is your dependent variable, electromotive force, EMF induced, maximum, and on the x-axis we will take the extension. And if we get a straight line, this is very important to state, many students forget this to write it down. If we get a straight line passes through the origin, then the relationship is valid. Because our relationship is what? According to the relationship given to us, how E and X are dependent. Look at this. This is a linear relationship. If we kept all other constant, E is directly proportional to the X. So it is the power 1. So if we get a straight line passing through the origin, so we can say the relationship is valid. Now the first part we have done, that is to determine the relationship between E and X by planning the experiment. Now to determine the value for the alpha, the given equation is this. So alpha can be written like E upon X B and under root M by K, or alpha is E by X is what? The graph what we have plotted is E here and X here. So the gradient of this graph will be what? E by X. So I have replaced E by X in terms of gradient upon B and into under root M by K. So these all are my control variables. I can put the values of the control variables, and by the graph I can put the value of the gradient in order to determine the value of alpha. Okay, now at the last, if you have any other additional details and the safety consideration regarding the experiment, you can add it on at the last. So I have mentioned in the heading improvement and safety consideration. So I think we can use cushion and sandbox in case of magnet falls. Here what we are doing, we are displacing the bar magnet. It may happen that the bar magnet may fall or may detach from the spring, so it may fall to the surface at the bottom part and the magnet may get damaged. So in order to have a safety precaution, we can use a cushion or a sandbox at the bottom of our lab where we are performing. We can check whether there is a permanent deformation in spring after removing the magnet, because we know the equilibrium position of the spring, we know the equilibrium length, normal length of the spring. So we can check whether the permanent deformation has taken place in the spring or not, because if permanent deformation has been taken place, the value for the K will vary, and that will alter the result and will provide less accuracy in our experiment. So these 2 points I think I can add to improve and for the safety consideration. You may add any other relevant point that can be considered. Okay, so that is how I have solved the question number 1 of your paper number 5. I hope you like it. The PDF notes of this is also available. The link is given in the description. Okay, you can follow the instructions in the description to get the free PDF of this handwritten notes what I have done right now and explained it in this video. Now at last, let us consider the marking scheme also, which is provided by the Cambridge. Okay, so the marking scheme says, defining the problem, X is the independent variable, E is the dependent variable that we have done. Control variables B, M, K and N are kept constant, 1 mark, 1 mark. Method, label spring supported by stand and clamp, done. These all are points cleared. Label magnet, done. Label coil position, done. Circuit diagram showing voltmeter, done. Methods of measuring X, the label ruler drawn parallel to equilibrium position and all is shown to us. Method to measure the mass of the magnet using the balance, that we have done. Method of analysis, we have plotted the graph, we have done this for the value of alpha. So all these points, if you go through the marking scheme provided, we have covered. And then additional details and what we have used, what we have done is we have used the question and the sandbox. We have keep the distance, equilibrium position, coil constant. We have checked whether the spring constant has changed or not. We have used this expression to find out the value of K. We have used the measure using the Hall probe. Okay. Also we have used the method to maximize E by taking large number of turns. We have explanation for the determine of maximum E using the slow motion playback. We have repeat the experiment and taken the value average of E, and you can add any additional relevant data. So this is how we have solved question number 1. In the next video we will solve question number 2 of the same series. Thank you.